Hi everyone, these are the fourth of the videos in the second playlist. Each of these questions look like they've only got, well these two look like they've only got the x written once, but each time they've got the x on the denominator of a fraction. So when I want to do something to any equation anywhere, anytime, I've got to do the opposites to both sides. Keep on talking about the obs. So what you do to one side of the equation, you've got to do to the other side of the equation to get the equation to balance. So if I want to get rid of a divide by x, I often have this thing I talk about called equals of times 1. This one stands for fractions. And one of the biggest things in maths that people struggle with is fractions. So usually I say to people, get rid of fractions first. If I'm marking a lot of students at a fairly high level and it's got a fraction in the equation, and I get, say, 30 students and you get 20 students who don't get rid of the fraction first, a lot of them get the question wrong. But the ones who get rid of the fractions first usually get the question right. It's just one of those things you see when you do lots of marking. So I say to people, how do I get rid of a divide by x? I times this one by x. If I times this term by x, I've also got to times that term by x. Student after student after student will have written here times by x, and they think they've balanced up the equation. But they haven't balanced up the equation because they've ignored this 3 here. It's like neglecting the 3 and thinking it doesn't matter. Like, hello, it's sitting there, it's there in the middle of everything. I times this one by x, I times this one by x, and I times that one by x. And then what happens? Any numerator can cancel out with any denominator when they're either straight above each other or you're multiplying. So in multiplying, we can cancel tops with bottoms. So I cancel that top with that bottom, and I'm left with just 2. So what happens really is I've gone x into x goes once, and x into x goes once, and I've really got 2 times 1 divided by 1. So there's the 2 times 1 divided by 1, which is just 2. So I just think of crossing out the x's and you're left with 2. This becomes a 3x, and that becomes a 5x. So it's really now like we're doing in the first 3 videos, that we've ended up with an x on the left hand side and an x on the right hand side. And either way, in that situation, we can go get rid of this 3x or we can get rid of the 5x. So yeah, I'm going to get rid of this 5x first. Because I'm talking about creatures of habit. If I remove 5x from this side, I remove 5x from that side. Again, we're balancing up the scales, and I'm left with 2. And I'm taking away more than what I had, so that's a minus 2x, and that's gone equals 0. And now I'm back to a fairly simple equation, though it mucks up a lot of people. A lot of people think plus 2, this is minus 2 to this side, and minus 2 to that side. Remember, we're not doing index laws, we're just getting rid of it. I'm writing it here to save some working out. So then I'm left with a minus 2x equals minus 2. And then if I want to get rid of that minus 2, I've got to multiply here. How do I get rid of a multiply by minus 2? I divide by minus 2. If I do it to the left hand side, I do it to the right hand side. Anything divided by the same thing, how many times does minus 2 fit into minus 2? And that's once. So the answer is actually 1, and look what happens over here. Anything again divided by itself is 1. I don't have to write the 1x, I can just write that as x. So a lot of people put an arrow of running out of room, and I can just go to x equals 1. I'd like to start the same question again though. And let's do it in a completely different manner. Get rid of that. And that's an x there. What if instead I knew that I can get rid of that plus 3 first, and in a lot of previous videos I talk about get rid of the 3 first. If I subtract 3 from that side, I subtract 3 from this side, and then I'm left with just 2 on x, because that's gone, 0, so I like to say gone, equals 2. And now I've got a much different equation I can solve. And again, there's so many things that you can do depending on what you prefer. What I'm going to show you at the moment is if this is just a fraction, I can turn it upside down. So all I'm doing is turning that upside down. So the x was on the denominator, now it's on the numerator. So if I turn this one upside down, I can turn that one upside down. And the upside down of 2 is a half. Then what can I do? I can then say, I'm going to get rid of a divide by 2, I can go times 2. And if I get any teachers watching this, there are so many choices of what I would do and what I prefer. So 2 into 2 goes once, numerator with a denominator. So that's a 1x, I don't have to write the 1, I can put the x, and the half times 2 is just 1. Yeah, different approach, some people prefer that. If I took that approach on question 2, I'd go take 5 here, I'd take 5 here. So this is the easy part to remove because it's just a 5 sitting there by itself. That's gone, I'm left with 4 on x, and I got 2 take 5 as minus 3. And you could try to think through what that actually means and shortcut, but again, it's just not worth it. If I turn this one upside down, I turn this one upside down, and the upside down of 3, by the way, that's 3 over 1, is a third, and we still have the minus sign there. Bit more complicated. If I multiply this side by 4 and multiply that side by 4, and then the 4's cancel out, they're actually 4 into 4 goes 1, so that's just x. And then what's really happening here, be careful, we've really got a 4 on 1, multiply the tops and multiply the bottoms. 1 times 4 is 4, 3 times 1 is 3, and it's minus 4 on 3. And of course, I could turn that into minus 1 and a third. Could go decimals, but more of a problem if you go to decimals. This one here, yeah, if we approach it like those ones, I could go take 1, take 1. But this is where I really prefer this system. If I times this one by x, I times that one by x, and I times this one by x, and I times that one by x. And let's have a look what's happened to the equation. The x's, I'm not going to keep nagging about all the details, they just cancel out. You can go back to previous videos if you've not seen me teaching these before. So that's just a 5, that's just a 1x, which is just an x. The x is cancelled, that's just a 3, and that's 4 times x is just 4x. And we've got the equation with the x's on both sides, which is what I was talking about in the first place. Creatures of habit, I can go take 4x, take 4x. If I wanted to, I could go take x, take x. But for today, I'm going to go take 4x on this side, I take 4x on that side, and I'm left with a 5. Now this has taken away more than what you had, that's minus 3x. And now that's gone. I do like to think of it as gone. It's actually 0, and that's 3. So now I can get rid of the 5. It's minus 5 from the left hand side and minus 5 from the right hand side. And I'm left with this minus 3x. Have seen many students over the years forget to put that minus in. It's like they just ignore it exists, or they think it's gone somehow. What's between the minus 3 and the x? There's a multiply, opposites of both sides. So if I divide this side by minus 3, I divide that side by minus 3. And then, again, 2 ways to think about it. I could just cross them out and say they're gone. They're not gone, they actually become 1. So how many times does minus 3 go into minus 3 to 1? So that's 1x. So I've got 1x. And here's a bit of a twist. Those 2 negatives, keep talking about 2 negatives make a positive. Marking year 12 exams and tests and assessments. It's amazing still how often students muck up with negatives. That 2 negatives make a positive when you're multiplying. So when you're dividing, 2 negatives also make a positive. So I've got just x is 2/3. And we've got enough on that. I hope it helps.